Doesn't need to push the button. Okay. Hello, everyone. Oh. So welcome to San Francisco. Welcome to IETF 117 auto session. Note where, and please be familiar with the RPI rules, processor working group process rules. So administrative, and please note that this meeting will be automatically recorded, and we need a minute taker. Actually, we have Jody to volunteer to take a minute. And so this is today's agenda we propose for discussion. So we only have 1 hour, so we want to break it down into two parts. The first part will, focus on the update of two charter items. We also very glad to invite Kat Chair to, discuss, potential joint work on the metric definition. In the second part, we'll discuss the future working group. So first, we'll set the context for discussion, and we'll invite our AD to give a few words. And so we have three proposals for recharter direction. So at the end, we'll pull for the direction. So this is a document status update. So as you can see, performance metrics almost ready for publication. We only need to get a confirmation from ANA because recently we actually have additional, ANA update. So this need to be evaluated. So current working group status, I think we, started 2021. You can see actually all the milestones we have already been honored. And we also have, socialized auto introduction, published in the Internet Protocol Journal. If you are interested, feel free to grab it in the IETF registration desk. So any agenda bash? If none, let's move to the first part discussion. I think Kai, are you online?
Hello, Jin, do you hear me?
Yeah, we can hear you.
Yep.
So I can run slides for you.
Yep.
Go ahead.
Thank you. So hello everyone, this is Kai, and I'm basically reporting the status of the working group documents for OAM and new transport on behalf of the co-authors. So next slide, please. Yep. So basically, for the OAM, I think we have resolved the issues, and it is ready to proceed. And for new transport, we got two issues from the AD review. So the first review is should we obsolete RFC 88.19.5 with the argument of, for example, the lack of SSC deployment, and the new document is functionally a superset of the old document, and also the concern that with multiple transfer mechanisms we might increase the complexity and of the protocol. And after internal discussion, our decision is to keep RFC 88.95, and based on the following reasons. So the first is that there are some ongoing efforts to implement this standard. So if we obsolete it right now, it may discourage the deployment of auto. And the second is we got SSC is also being used in other RFCs, so it might still get some chances to be deployed. And then and also there are some like dependencies between this document and RFC 88.95, so we decided to keep it. And the second issue is for HTTP2 and HTTP3, there's a feature called server push, and in the previous versions, we designed some mechanisms to leverage this feature. but we got some pushback from both the AD review and also from previous like HTTP GIR reviews. And the argument is server push is not a widely deployed, widely implemented feature, and the gain of using server push is not significant except for some extreme cases. So after the discussion and investigation on other protocols such as gRPC and some others, our proposal is to move server push feature into appendix. And the reason why we do not keep it in the main text is based on the arguments and feedback from the reviews. And the reason we did not remove it completely is because we still see some values of the server push feature. And if, for example, with the development and deployment of HTTP 2.3, there might be a chance that this feature can become useful in later, basically as a technology evolves. Okay, that's basically the update for these two documents.
Yeah. Okay. Thank you. Thank you, Kai. So Martin, I don't know whether you had a chance to. So we can start for the first one, easy one about the OM. I don't know if you are happy with the clarification provided so far.
So I've not had the opportunity to review the PRs. Like I think we're pretty close. I'm a lost date on OAM. New transport, like I think Kai and I are making pretty rapid progress. So when we say SSCs being actually used in RFCs, you mean SSC-like mechanisms, correct? Like where there's no reference to 88. Well, I just quickly looked, and 8650 does not have a reference to 8895. Are you just saying that like SSC type things are used elsewhere?
Yeah, I think it's used elsewhere.
Okay. Yeah, I mean, there's a lot of HTTP-based stuff out there, and clearly, like HTTP reviewers have not managed to like enforce best practices across everything. I think we have a lovely opportunity in that we got a good review and we're able to pump the best practice. And as much as the only thing that's at all compelling to me about keeping SSC is the idea that like some people are trying to implement it. They can implement something that's deprecated, like that's not going to break anything. And of course, if whoever's implementing it is here and they have some insight on why they want to do SSC rather than long pull, other than the fact we are just now publishing this, I'd be interested to hear that.
Yeah, just for the record, in the new version of the draft, you see that this is not recommended to use SSC, and the new transport should be used instead for the further implementation. I think one of the reasons they indicated about that they don't want to obsolete it is there's one implementer that said that they recently have this, I would say, SSC, which is in their product, and they don't want that to use it as a negative signal. For me, it is not, but I'm hearing what they are saying. So it's up to us to see whether we can live with the, I would say, just the soft recommendation in the, I would say, in the ACC to say that, yeah, we know that ACC is there. We don't recommend to use it. Please use this one, but we don't obsolete it. So it's just, we have the trade-off between the two of them.
Like, it's very alluring to get into these really long arguments about the signal we are sending to the community with like these things, and ultimately it probably doesn't matter. In the interest of housekeeping, like if it were up to me, I would say it would probably obsolete 8895, but I'm disinclined to die on this hill. We could talk for a little bit longer. Like I said, if there's input from the implementers of 8895, because if I read your wiki page correctly, we had no known implementations of 8895 until this thing that is ongoing, right?
Martin, can I just say a word? I think one thing, probably one group of people who have the most knowledge would be Danny and Ingmar. But unfortunately, both people are on vacation. They couldn't join the meeting. I believe they do have SSC implementation. So would it be possible that we wait a little bit or we send an email until, for example, both Ingmar or Danny would confirm? Would that be a reasonable proposal? Or because both
Yeah,
on-
like I mean, this isn't a huge issue, but I think we can also take like a week or two to wait for people to get off vacation, and like I would like to have a little conversation with them, and if this is super important to them to keep it not obsolete, I think some language saying like with the new document saying this is the best way, we believe this is the best way to do it, and reference 8895, you know, appropriately. I'm sure we can find language that is fine with me, no matter what the actual header says. Yeah. Okay. Thanks.
Yeah, your language sounds very, very reasonable. Actually, I buy it.
Okay, let's move on. And next is Adrian, and we'll give a presentation that, for the metric definition.
Okay, I hope I'll do this quickly. I am CATS co-chair. What is CATS? CATS is a framework for distributing computer network metrics in order to allow the network edge to steer traffic to the appropriate service instance to perform that compute function. So it's not on path, and it's not client-based. Next slide. Compare and contrast this with the regular Alto photo picture. I know there are other variants of this, but the essential here is that the host is being helped to make a decision about server location and instance and maybe path based on information that's been sucked into the Alto server. Next slide. There's a potential and rather more complicated figure that we could draw. Nobody's really proposing this at the moment, but you can see how Alto and CATS might go together so that the host is making, or the client is making a choice about the set of server instances to target, pushing that out as far as the edge of the network, and then the normal CATS processing takes over. So key in this figure is that network information is being used by CATS on the right of the picture, and being used by the Alto server on the left of the picture, and similarly, service-based information is being used by CATS and by Alto server. So there's a pooling of, or a commonality of the metric information that's needed. We already know how the network stuff works, and so the big question is, how do we put metrics in place for compute services in a way that CATS can do it, and can we possibly do that in a way that Alto would like? Next slide. So in CATS, we're interested in the network stuff, topology, capabilities, state. Part of that is latency, but that's all in the pipeline. We know how that works. And then we're also needing the compute information, the server locations, capabilities, state. CATS is a very, very new working group, so we're only just starting to look at that. And we'll need to know things like what are the processors, and what is their current load, and their ability to process particular requests in a particular time frame. We are guided by needing standardized metrics that everyone can understand, so that different implementations can all play as part of this ecosystem. We want those metrics to be easily combinable, and also easily combinable with the network metrics. What we've learned from traffic engineering is that if you can manage to get your metrics very simple, then it's very easy to proceed. If you get them complicated, you will probably burn. Next slide.
Can I ask clarifying question?
Are you an AD or a or a participant in the community?
Participant.
Can you wait until I finish the
Yes.
slide? So it seems to me that there is quite a potential overlap on these compute metrics between CATS and Aalto. Aalto is quite possibly interested in this. And if so, would it be nice if those metrics could be common across both architectures? And I'm pretty sure that there's an understanding of server metrics in this community that CATS could learn from. So I'm going to be suggesting with the chairs here that we maybe have a joint interim meeting to try to pursue this a bit further. CATS is probably going to have an interim meeting to pursue metrics anyway. Martin.
Thanks for coming over, Adrian. Martin Duke, Google. Can you go back to the cloud slide, the one with all the diagrams? I'm like a dumb TCP guy, so when you have more than client and server, I get confused. That box in the upper left says host, which I think is the Aalto client in this model. Is that that's
where the Aalto client.
Okay, so is that like a human being, or is that like a CDN steering thing that the ISP owns, or what?
I think I picked the word host deliberately here. So I see this as something that's running an application.
At like an end user device.
Yeah.
Okay, that's very interesting. All right, well, lovely, because Aalto, I mean, all the people associate a lot of concepts with Aalto. Aalto is fundamentally just an API between some sort of network database thing and a client. And all right, thanks.
Joe?
Through Huawei. One question that comes to my mind is, I totally agree that like metrics are common, so we need synergy. We don't want same thing defined in two different working groups. But in this figure, is there a system in which both Aalto is making decision, that there is an Aalto client looking at information from Aalto server, making some decision, plus CATS also making some decision? Or are they two different systems? Maybe the metrics are the same, but they are not working together.
Right. So that's basically the three slides I had, where CATS is on its own, Aalto is on its own, and maybe both things are happening. And if you follow that green line from host, where it starts, Aalto would be making the decision about the set of potential service instances to be targeting. So out of the whole global conglomerate of service instances, Aalto would be filtering down to, here's a pool to target, pushing that through, and then the CATS system is picking the individual one.
Rachel?
You can be quicker, please.
Yeah, please be quick. We run out of time.
Oh, okay. So I'll try to be very quick. I think, Adrian, that's actually a very, very good comment. I think a metric would be very interesting. I just want to clarify a little bit about the architecture you have in mind. For example, for a lot of steering things, for example, I always view like computing aware some kind of load balancer, for example, Nginx, something like that, right? And oftentimes a common metric would be something like, you keep track of the current number of backlog connections. So therefore, and then you do a load balancing, for example. Would those type, and then oftentimes, for example, very common one, by the way, here I'm high from Geneva, from CERN, and for example, a large type of service instance selection is, for example, here is you send some kind of pilots. You send a pilot, you want to essentially probe a little bit to get a sense of latency, computational latency on all the devices, and then they become part of latency. And if that's the case, then those information, if we inject into Aalto, then we're going to have some kind of very real-time provisioning things. We either collect information from computing instance independently and we merge them, or somehow they become overall, for example, aggregated total latency. Oh, too long? Okay, yeah. But overall, if we can clarify, of course, we can discuss offline. But overall, I'm just trying to understand the structure.
Yeah, so I understand your question. We are simply at too early a stage in CATS to have an answer to that question. And that's the thing we need to sit down and do.
Wonderful.
So if it works with the chairs, what CATS will do is come up with a couple of dates where they think that an interim would be a good idea, float them to you and see how we can mesh.
Yeah, thank you. Thanks, Adrian, for wonderful discussion. Yeah, let's move on to the second part. So here is the chair view, actually a little bit subjective. We think this auto has been around for a while. So we, thanks, auto design team, actually sustainable, trustworthy worker, actually not just define standards, but also, spin on the worker to fix the open issue on the GitHub, define, also try to write the software to validate the standards. And however, besides the base protocol, we see, very few, many extension hasn't been adopted, and few deployment are be discovered for many different reasons, and the new applicable use case continue being proposed. So that's a current situation. And so this scenario we look at, not we look at scenario auto client can be the placed on at the host, but also the auto client can be placed in the edge node or orchestrator. This just to keep in mind. And some observation I want to highlight, the hurdle really prevent this deployment from our view. We think like, data source integration, such as topology, compute, and metrics. We really need to figure out how the provision protocol can be provision auto server to generate auto specific information. So this is something we should keep in mind. And for the direction, we have two proposals. And the first is the recharge direction. We focus on auto maintenance, fix the integration complexity, ease the integration with data source. Second direction, actually, we can declare our success, make auto dormant. And with that, I want to move to AD. A few words. Martin, do you have any comments on this part?
I didn't have anything prepared, but sure. I mean, I think your assessment's pretty accurate. I can see a gap in trying to aggregate this information into an Alto database. I also don't think that's Alto, and I really don't think that's something in the transport area. So Rob Wilton's here. He's the Ops AD, so he's a little familiar with the Ops or Management AD. Sorry, it's an inside joke. And I brought him here just to help me sort of evaluate these use cases. I mean, if we want to do a aggregation thing, I almost think we need to pretend like it's a new working group. And I don't know if that means we have to have a BOF necessarily, but maybe finding a sponsoring AD that is interested in looking at this problem and seeing if there's something to do. If that's the direction we want to go, I don't want to reduce your slide to that proposal because I know there's more there.
Yeah, perhaps it would be easier for Rob to be aware of the proposed action point. The other one about resharpening, just after the three tweezers we will have about the proposals, and then that would be better for you.
Okay.
So just as chairs, we are not, I would say, we are trying to be neutral on the two directions. We are here in both directions. So it's also up to the working group to tell us whether there's energy to continue or not. So please wait until the end of the teasers to react and contribute to discussions.
Okay, next so Richard, we can the first charter proposal.
Sure. I'm not seeing my slides. Great. Can people hear me okay?
Yeah, just stick to your time, 5 minutes.
Sure. Okay, I'll start. And my presentation is to talk about source bound implementation. And we're focusing on using IETF mechanism because there are many ways to build, like, for example, Martin mentioned how to build auto database, or talk about evaluating how to build auto database or auto essentially information from IETF mechanism. It's most focusing on the auto-based services. It's a bunch of work, but mostly this one slide done by me, Sabine, and together. Next slide, please. So if you look at the overall the auto structure, essentially I would say it consists of 3 components. The first one is the green one, and the green block is what we call essential northbound. It would include a bunch of abstractions and services provided by auto, essentially auto information, right? Cost and so on. And then you define the transport, and then you define discovery. The evaluation would be this part probably is very well defined and it's quite well specified. You give this specification and people can implement quite easily. Then on the right-hand side, you also have the second component, which is OEM. It used to be missing, and now lately we're making very good progress. I think that's great. The major missing piece, at least for more and more for people who are doing implementation and deployment, is source bound somehow is missing. And of course, we can see some source, essentially there are 2 points of view or 3 points of view. One is auto database somehow should be easy, and it turns out to be hard. The second point of view will be, okay, and auto information probably should be secret sauce. And someone should really come up with good way to compute stuff and so on, and really that's how we compete. But somehow the problem turns out is even for very basic standard auto metrics, for example, standard and traffic engineering metrics, it's very hard to compute. So therefore, they really become a major impediment for the deployment of auto. Next slide, please. To be concrete, and here is a very concrete thing to talk about how to implement a very basic auto cost service. So here is, you have a network in the middle, imagine it's telco, it's network N. And your goal is very simple, is you really have already configured the links, the metrics, all kind of metrics, standard metrics, for example, and the delay, and standard T metrics. And you want to compute, essentially auto wants to compute aggregate end-to-end metric, M, for the given source for given destination. Is it really trivial? And it'll be very easy to implement. It turns out to be hard. Why? You look at it, essentially there are 3 subtasks. Number 1, you have given source and where's the ingress point. It might come in from A prime or might come from A. It's actually not easy, we'll see. The second one is you really need to find out the set of links traversed before you can compute the total auto information. The network can be structured. For example, you might have a OSPF, therefore you might have area 0 or 1, for example, then you compute path from A to B. And then you have second area, for example, from B and all the way to G to your egress point. Maybe your IGP would pick B, K, F, G, but then you really have some kind of traffic engineering and would also create some kind of shortcut and become, instead of BKF, it becomes BF. So therefore, those are the issues. And of course, you can argue that, this information is somehow owned by the devices, by the same vendor. You can really do that. Actually, there's some vendor doing that work already, and you take all the configuration files, you become vendor specific. It's quite complex. The question is, how do you implement it? Next slide, please. So this is one of the first major implementations, and this really done by Benox. I believe is really, they said this system has been computed, I believe deployed in 15 networks, maybe 20 networks, and so on. So here is how they solve the problem. It's what we call essentially routing system listener and sampling-based deployment. If you look at the upper left corner, and there are a bunch of listeners pairing with all kinds of routing systems. So what's the problem they're trying to solve? They're essentially trying to compute the routing state and the links, set of links traversed. Do we have problems? Yes, we do. For example, IGP passive pairing can be complex. There'll be all the structures, and then you have to also replicate all the behaviors from topology data. And you have a new traffic engineering things continue to emerge, segment routing and so on. The second one, of course, is you also have a lower left corner and all kinds of Xflow things. What they're doing, they're trying to compute the central ingress point. And all the kind of sampling algorithms, for example, Xflow and so on, they must have traffic. Oftentimes, they don't scale very well. Next slide, please. So next one is implementation deployment really being deployed at CERN at WSCG and really based on persona data. And here is, I'm not going to go to all the details, based on RFC 792 and then OWASP and so on. And you also have kind of issue, right? SMP, you have all kinds of node aliasing, multipath aliasing problems. And then we're using personas, is running production and so on. And unfortunately, performance Sonar servers oftentimes quite different from our targeting points. All kinds of very, very complex anchoring algorithm to really get our data. Next slide, please. So what are we proposing? It's very simple. It's to evaluate, guide, and propose solutions to auto source-bound implementation and deployment barriers. We're not going to really like boil the ocean and look at all the fancy things. We want to focus on computing auto-based service, not all the fancy services, and providing only auto standard metrics, and only be using IETF standard mechanisms. 3 groups are interested: CERN WSAG Auto Server and a bunch of people over here. And the second major deployment is Banox, and Danny and Ingmar, they are supporting this one. Of course, they're on vacation, but we follow up and so on. And third one, of course, is Telefonica, and which is Luis, and all the kind of efforts. Some more details. For example, we want to be focusing on using BGP-LS implementation. We want to give all the details, how much we trace, and so on. And then there's some ongoing non-chartered source-bound implementation. There'll be essential side effort, but we're not going to spend time on that. But just tell you, there's also a lot of effort really pushing implementation. It turns out to be quite hard. I think that's all. I use up my time.
Thank you. So let's move to the second talk. We'll take a question, at open discussion.
Sure.
Hello, everyone. This is Luis Contreras from Telefonica. I will cover the topic about the extension of Alto by using BGP communities. So next, please. So the BGP communities are quite extensively used by operators. So typically, by the means of BGP communities, we aggregate, summarizing the point, we aggregate IP prefixes, and we can apply different policies, typically policies related to routing. So preference of the pinning point and so on and so forth. As I said, this is usually extensively used in operators' network. On the other hand, we have Alto. Alto, what is working with the concept of PID. The PID is similar to the idea of BGP community, a kind of aggregator or grouper of IP prefixes, right? But certainly the way of aggregating in PIDs and BGP communities is totally decoupled. So the idea would be to extend Alto with the purpose of handling BGP communities instead of PID, or complementary to the usage of PIDs. So the BGP communities are advertised regularly by BGP messages. So the point here would be to integrate, to extend Alto to being able to parse the BGP messages for integrating and processing the BGP communities information. So as objectives of this proposition of direction would be to allow Alto to process the community information from BGP, to provide the network map and the cost map based on BGP communities instead of the conventional PIDs, and to facilitate and foster the integration of Alto in operational networks. So somehow aligning the way of running the operational networks that are going in this direction of BGP communities. Please look the figure. So the impact, let's say, of considering BGP community could be both in the software interface, so how to retrieve this information, parsing the BGP messages for collecting this information, also in the processing, so in the internal of the Alto server, in order to process this information for creating the different maps, and as well, probably how to consume Alto information, so allowing the Alto clients to request the information to Alto server based on BGP community. So next, please. So the aspects that we identified that could be addressed in this line of action would be how to use or apply the concept of BGP community in Alto compared with the PID. The point here is that we could play with an additional flexibility because, as I said, BGP communities is a kind of grouping of IP prefixes. So we could have a relationship one-to-one between BGP community and PID, or one-to-N or N-to-1. So there is a flexibility we would need to deal with and understand what could be the implications. Similarly, how to retrieve the BGP community's information. So either processing the BGP messages, either configuring the Alto server with the BGP communities, maybe leveraging on the OIM interface in progress to become a RFC, or maybe other mechanisms that we could identify. Also to analyze the impacts on the maps. So with this possibility of having mapping of one BGP community to MPIDs, there is the possibility, let's say, of the situation of creating maps from one origin, let's say, to many destinations, or from many to many. So also it's needed to understand what could be these implications and how this could reflect in the different maps. And finally, yeah, the BGP community representation in Aalto. So how to represent this in the format of the different objects, if they're representing this as an abstract network element or in any other way of representation. Apart from that, the normal security considerations of dealing with BGP communities. Next, please. So as next steps, the idea would be to collect feedback from the working group and to consider this as a part of a new charter item of Aalto regarding operational evolution. That probably could include maybe other aspects as well, like security or so, and basically trying to ensure the interoperability between different implementations so that yeah, we can have this kind of a standard way of working. So yeah, that's all from my side. Thank you.
Thank you, Luis. Yeah, next, Jody.
Yeah, can you hear me, Shin?
Yes.
Okay.
5 minutes.
Thanks. Yes, I'm going to be talking about a proposal to extend Aalto with computer information to support edge service placement and selection. This is work that we're doing within the Aalto working group. Includes Telefonica, Nokia, Benox, and Qualcomm, and other members in the working group as well. They pretty much align with this as well. So in the interim, we discussed the use cases quite extensively. So, what we're presenting here is an abstraction of the use cases into this notion of service life cycle. And here, sort of, we do like a gap analysis, if you will. So, when you have a new service that you want to deploy at the edge, the first step is deployment. So, to make that decision of deployment, you need to have information about communication cost and compute cost. Once the service is deployed, then the next is to actually instantiate the service and actually do the selection of the service. And so now let's, if you consider service deployment first, who needs the information required? It's compute and communication. Who needs it is the service provider. The service provider using the network wants to know the compute capabilities, the distributed compute capabilities, as well as the communication capabilities. And we think that Aalto is ideal to provide this use case and implement this use case, because that's the exposure of network information outside the network operator and into the service operator. As for the service selection, here there are two problems. One is two objectives, two features that we need to that are looking for here is service selecting the service. Where do I connect to? Services are replicated, so you have multiple choices, and then path selection as well. Again, you need compute and communication information to make a proper decision there, and who needs it? So the network provider needs this information as well as the application, the application client, also to make this the service selection. And here a portion of this has been dealt from the CATS working group, and we think that also Aalto can cover the gap of service selection too. Just a note, a recap on some of the use cases. One, these are use cases that are actually real. If you look at, for instance, the XR computation, these are actual technologies that are being developed. The case of a floating compute from the glasses to the phone, from the phone to the edge, and from the edge to the cloud, and making this decision based on compute and communication. Also to save energy and to of course make sure that the quality of service is guaranteed. So that's and then of course the emerging distributed AI applications as well. So the proposal here is to work on an informational draft that would cover the following items. First, gap analysis. focusing on the life cycle of the service, understanding where are the gaps, and how Aalto can cover that. We already see that the importance of covering the case of deployment, which is not covered in any other working group in the IETF right now. So, and that's key to enable these capabilities. Then analysis of other related activities in the IETF to avoid reinventing the wheel. Feasibility analysis to extend Aalto with compute information, southbound and northbound interface feasibility. And then looking for analysis of interactions of between Aalto and other working groups, and has been mentioned by Adrian, specifically with CATS. And this is action item already to discuss interactions in an interim meeting. So I think that covers this presentation, Chin.
Thanks, Judy. Yeah, I think we still have 20 minutes. We actually on time, and these 3 proposals actually focus on data source integration and really to automate this kind of operation. I want to open floor to the audience to hear what you think about these 3 charter proposals.
Yeah, don't be shy.
Go ahead, Richard.
Oh, okay. I'm asking very short questions. So what exact format? So should we advocate for what we want to propose, or we should discuss and so on, right? So I'm just sorry, and you can give a guiding advice first, and then we'll follow you.
Yeah, I think first we can take some question about the clarification of the scope of is proposed here, so that the people understand what we are proposing as a working group, and then we can then move on.
So I guess I don't 100% understand the relation to the few proposals, because Richard kind of had this southbound. We got to do southbound, and then I saw instantiations of southbound. But so my understanding of this whole space before 40 minutes ago was that Aalto was the waste, right? Yep. And you have this network, and maybe it runs OSPF, maybe it runs ISIS, and maybe it's statically configured, and maybe BGP matters, maybe there's CDNI. That's great. All this stuff, but if you needed to consume topology information, here was Aalto. You didn't have to worry about all that stuff.
Correct.
And
that's no problem.
And if we're gonna try to standardize the southbound thing, then that just moves the waste. So why use Aalto if you've got this other thing? Now maybe it's a funnel, mm-hmm. and we need the Aalto is just like a container or a framework, and there's all these metrics that shoot out the bottom, and there's all these collection methods that come in the top. Or I guess I've flipped the directions there, north and south, but regardless. So I really don't want to discourage any of this work. It feels to me like we'd be much better connected with the right people if CATS went and did a metric thing if they decided to use Aalto, that they took on the role of standardizing a new Aalto metric, and some Aalto people went over there to make sure it's fine, the same way that you develop new applications over QUIC or whatever, right? And then similarly, if there's one design to get data from BGP, that actually we do this in BGP, right? And so on, because this is not a huge group. It's not. I mean, they're dedicated people here, but we just don't have the critical mass to do a ton of reviews on things. And obviously we're going to be lacking subject matter. We will lack the subject matter expertise to evaluate CATS metrics if CATS isn't involved, and likewise with these routing things. Anyway, I've said enough. I'll let other people talk.
Sure. Can I respond very quickly, or maybe we should take a turn? Oh, Luis.
Okay, yeah, Luis is on the queue.
Yeah.
Yeah, Luis from Telefonica. Yeah, I think that we need to look at Aalto not like a single. I mean, not thinking on single metrics or single problems like BGP and so, but it's a kind of aggregator. So the power of Alto is precisely the possibility of integrating all this information. So the point is to solve the different ways of collecting the information, maybe BGP communities, BGPLS, compute to whatever, but with the final purpose of exposing all together or aggregating. So that is essentially the point, I guess.
So Richard, do you have
Yeah.
any
So
follow-up?
yeah, I would like to follow up a little bit is the following. And I think, Martin, you give a very good comment. So basically, Alto is the thin width, but this thin width is only somehow defined on the northbound. The major problem, if it's becoming very clear in, I think, from the deployment of Benox, right? And if this is very easy northbound, you're not going to get 3 best papers or worse, right? And they got the Connex best paper because so fancy to implement it. And they get RTF, Applied Networking Research Prize. I think very likely they're going to get the SIGCOMM Software Systems Award this year. And why is because it's very difficult, but it doesn't have to be. If you want to have secret sauce, by all means do that. But somehow for the standard metrics, it really should not be this difficult. Because why you're chasing a moving target? For example, you have OSPF, ISS, and you collect a metric. Suddenly people build kind of overlay on top of it, for example, segment routing and so on. So that somehow the source bound becomes very unstable. I think that's one of the lessons where Luis talks about the implementation is very unstable and the people keep on adding new stuff. So therefore, eventually for ours, for example, we're looking, number one is we provide guidance, talk about, for example, okay, if you add a new, for example, T component, should you tell us? And if, for example, our deployment, if you add, for example, noted, you add a new stuff, should we know from the source bound? And so therefore, we can really know, we really should integrate this stuff. Then there's some many other ways we like make all the essential integration of northbound to be as clean, as simple as possible. I think that's basically what we're proposing. Be driven by actually 3 very, very different approaches. Benox is peering, and Telefonica is PGPLS, and CERN WLCG actually is measurement, and now moving over, for example, some customized of traffic engineering. Together, eventually, we really want to have guidelines, and we want to have, of course, one big lesson we learned is we're not going to propose anything experimental or research, but we're building all kinds of systems, for example, and they try to really retrieve all the routing information. So therefore, essentially, we're trying to say what guidance, and even for information, then there's also some other mechanisms. Of course, they might become ready or not, and we'll see. But I do want to give one last comment. I think you give a wonderful comment is we really should have domain expertise. So therefore, I think we really should interact a lot more with the people from the routing domains, and of course also with CAS. I think those are wonderful things. I think if you can see that, and this working group are trying very hard, really engage. For example, quite a few of us are in the time vary routing domain, and we're all getting engaged into the TAS and so on. So therefore, that's basically actually a wonderful comment, and we're trying to do that.
Thank you, Robert.
Rob Wilson, Cisco. I was trying to understand what a southbound API would look like and what would be new. So we already have BGPLS, we already have Yang models, loads of those being defined, loads by vendors, loads by OpenConfig, and protocols for getting that data up for the devices. We also have IPFix already defined. So we have already lots of this data that's available with APIs, standard APIs, standard Yang models. Taking a long time to get some of that and get it aggregated together. We also have teams that are already working to sort of aggregate that data from those 3 sources into, say, Apache Kafka. That work is happening in OpsWG at the moment. And so I'm wondering what a southbound API would look like that's different from that. Because if you're suggesting another protocol on the devices to export this data, I would be heavily against that, because I think you'd just be doing more work, doing the same thing again. And then I'm thinking about, well, if the work is something sitting in the, I don't know, Alto server that's doing this aggregation, what does that look like? Is it just saying pull this data from these places, or what actually does that end up looking like?
So I'm going to give very short response, and then I'm going to ask Luis to give a response as well. So for example, a very quick short response would be for number one, we're not proposing to do any like protocol work yet. And number one, we're really looking at all the guidance. For example, the management protocols. For example, you go to network, you tell us you're running, you should somehow guidance, you should really like, for example, if you divide it into multiple areas, you want to make sure you configure, you know, all the, for example, BGPs in the correct way. You really should put information from all the correct ways, and you really should pull information from area 0, area 1, area 2, they all should be pulled in the right way. And therefore, you can really build a topology database. And then if you really, for example, you start to have overlay, for example, you know, all kinds of segment routing and flexible algorithms, you build on top. So therefore, notify us. So therefore, we know we're going to do the integration. And then that's essential. Those are the ones we're focusing number one. And it's tempting actually really do, like, for example, some fancier protocol work, for example. What I will look at a personal level, that's very total personal opinion, is I don't believe that actually the control system would be stable. People would continue to invent new control algorithms. And ISS and OSPF, and then you have, for example, all kinds of signaling protocols on top, and you have all kinds of control. But typical, actually, oftentimes, the control plane or the data path oftentimes is stable, more stable. You're not going to have a lot of evolutions very quickly. That's why, for example, essentially that's the argument of P4 or all argument of software-defined networking is that part oftentimes a lot more stable. We can actually, even possible, can directly pull those information. But of course, not really by, for example, like forward network would really go there and pull, for example, the configuration files and then compute stuff. We want actually a mechanism, of course, we're not proposing it, and actually we're implementing. We even now have a very basic prototyping is we can conceptually even dump the forwarding table. And therefore, we can really do both the topology. We can also do, for example, the routing. So therefore, it's a lot more stable, essentially, is you do all the fancy computation, you do all the evolution, but we fetch it. So therefore, we can really know.
Thank you, Richard, for clarifying. Yeah, so just to provide more clarification before giving the floor to you, to Luis, is actually in the current OI model we have in the Alto, the way this is glued to the data source is out of scope. So that part is really missing on if you want to have the full integration. So there will be some modification to be done into that data model. This is the kind of things that are really missing. This is more operational. This glue is currently out of scope because of the scope of the working group. This is one of the, I would say, tracks that the group is currently proposing. Luis, please.
Yeah, thank you. The comment was precisely in this direction. So the objective would be to reuse whatever is there, not getting the things, BGP communities, BGPLS, but we need to process them and trying to represent into the Alto stuff, so the objects and so, in order to generate later on the integrated information that we can expose outside toward the applications. There could be aspects that probably there is no solution yet. That could be the case, as Adrian was mentioning, the compute our metrics and so. Probably for that, we can figure out how we could collect. Maybe not the standardized, but understand what kind of metrics can be retrieved from whatever system or so. But for all the models, for sure, the objective is to reuse that. Simply, the point would be how to integrate that into the Alto objects so that we can represent everything. A clear example is, for instance, the performance metrics. So we are collecting the performance metrics from IPPM and so, but we integrate that with the topology, with defining the way of how to glue all this information together in the internal of Alto, so that the cost map can represent performance metrics, for instance. So we are not reinventing the metrics, or we are not reinventing the way in which we can collect the metrics, just simply how put all the information together.
Okay, and I don't know Alto, so that puts me at a disadvantage here. But is that something that's worth standardizing? As in, if you're deploying Alto already or using Alto, have you're already doing this for the metrics you care about? And I don't know with Alto what its data formats are like or how constrained it is. Isn't it something where the operators and the people deploying Alto will choose exactly which things they want to go into it, and they'll just get that data and put it in? So I'm sort of trying to work out what the value is in standardizing that commonality. I mean, if the draft's going to say get data from these possible sources and put it in, that has relatively low value to me. So I still just struggle to see where the value is.
I can comment. Two different aspects. First, having a common way of retrieving these values, let's say. So we need interoperability on what is the kind of information that we can get from different sources, right? So it's such a way that we can integrate with the same semantics, the information. And later on, how to expose also in a standard way. So because the main aim of Alto is to expose to applications. So we need to have a common way and a standard way of exposing what could be the characteristics that the network is providing in general, the network map, cost map. So to have a common language for all the consumers that could require the information from the network. So a common way of, a standard way of retrieving the information so we can process, and also a standard way of representing the network to consumers.
But that sounds huge to me. I mean, the bit of doing standard models up to the consumers, isn't that like another set of Yang models? It just feels like a big thing, if I'm understanding correctly. I mean,
The consumption by now is not based on Yang models, it's Alto protocol, Alto objects, and so on. For the retrieving information, yeah, we can leverage on Yang models, which is a standard way of representing the, for instance, the metrics or the values of the IGP metrics, right? So that would be let's say the effort of standardizing things would be in leveraging on different implementation from different routers, different whatever, that we can get the information in the same manner. So we can integrate easily, right?
Martin Duke, Google again. So this is the part where like my cartoon of this is doesn't think that this is complicated. And you explain why it is complicated. So let's forget the weird metrics like latency. I recognize we have no way to like accumulate. We have no system to like accumulate latencies of all the networks. But for the simple case of a cost map, I'm running a link stick routing algorithm probably. I have an entire picture of the topology, and I can just run Dijkstra from the client to wherever to get the cost map, correct? Like is that straightforward, or is that more complicated than I think it is?
Martin, can I just give an example? For example, how do we even know where the ingress is?
Well, you have an Alto client that has an IP address.
Right, it tells the source address, but somehow, for example, enters into from three locations. And how do you know from which point it enters you?
Well, isn't that part of the Alto request?
Well, no, client gave you a source address might be outside your network. For example, a client might belong to, for example, a small network. For example, a client might be inside, for example, CERN. And then CERN would have two ingress points and into, for example, ESNet, which is backbone. Therefore, you even don't know.
But that's not a northbound problem. That's. I'm sorry. God damn it.
Yeah, that's southbound. Right. Yeah.
That's a current Alto problem. That's not an accumulation problem. Like knowing what the client IP is.
Your accumulation, you must have starting point. Here, for example, for this one, even like sourcebound, you even don't know where the accumulation starts. Yes, you can compute the Dijkstra algorithm from given point, but from where, and you can point A or point B.
Okay, thanks.
So just one comment, Martin. So in this idea, I mean, at the end, with Alto, what we can, thinking on the example for the integration with the Telefonica CDN, what we have there is the different distance, if you wish, but with different streamers. So that is I mean, we are not just representing a relationship between one PID and one other PID, but one PID and multiple PIDs. It could be a media delivery system. So based on that, the application can take decisions. So it could be the raw metrics or could be some processing, but assuming the raw metrics, that the value is the one to many. I mean, to have the selection, the choice.
Well, Diego Lopez, we have been working, I mean, I work for Telefonica as well, but in a different unit from Luis. So I'm not sure that we have totally aligned views on this, but we have started some. I'm going to sit over here so you look at the camera. Oh, well, whether should I do with Rob? That is another deserve the same respect, I guess. Anyway, no, seriously, the idea is that we have started some effort recently, and during this meeting, I have met a few people that could be interested in what we call capability exposure. I would say it's a way of telling potential users, and not necessarily end users, but probably providers that are using about how the network is, how the everything is running, which are the capabilities, what can we offer, and what is important for us, or at least for, I guess, our groups, is avoiding that well, someone somewhere else is reinventing the wheel, because we believe that we have here the wheel. And that's something that we are trying to, this in the northbound interface, and even for the southbound interface, it will be important as well that if there are units inside our company or even elsewhere that were willing to publish some additional information that could be used by the Alto server to enhance the calculation of what they're exposing, is to simplify it and say, no, you have to go BGP, you have to go, for them it's easier to use the interface or the API that Richard was mentioning would be interesting. That's, in summary, it's about exposing capabilities and simplifying how the information goes very much in the direction of the waste you were mentioning before.
Ayub?
Hello, Ayub Mesous, Fujitsu Research of Europe. Thank you for your presentation. I have just a quick comment. I think it aligns with what just Martin and Luis earlier mentioned. As I've been following the work done as part of the Alto work group, I believe the aggregated data and the metrics using the Alto protocol would open the way for a wide range of real-world deployment and application. We already identified real-world problems that have that can be efficiently solved using the collected data through the Alto protocol. And over the last few months, we did a couple of interim meetings. We already identified such possibilities that we really wish to have the chance to work towards achieving. Thank you. Ayub from Fujitsu. Yes.
So it seems that we run out of time. Actually, we have a lot of discussion, haven't reached a agreement. Do you think we should? Yeah, we try to wrap up. And
can I wrap it up?
Yeah.
All right. So thank you, everyone. This has been very informative. We have a lot to think about. I'm going to talk with some of my colleagues on the ISG on how I'm going to move forward. This group, no matter what, will remain open for a while because we have these documents you're still going through. This community can exist forever, no matter what we do. There can be a mailing list. I would encourage people to go in, certainly go to the CAT Syndrome, et cetera, because I think there's also work to be done regardless. And I don't know that we need to have a working group meeting in Prague, unless things coalesce around a charter a little more quickly than I think they might. So I would anticipate be closing the group in the next month or so by any means. So I think we have a chance to talk about this. If people have additional information they want to share, the list is there. I'll monitor it. Other people will monitor it. So let's continue to have this discussion. And thanks again for everything. I think this is Alto is a good protocol, and I think it's starting to see some traction, and that's great. Okay.
Yeah, we're done. Thanks, everybody.
What you said was